Welcome everyone. Slowly tuning in here on our kickoff live stream featuring the Polkadot SDK. So let's give it a couple more minutes as people kind of slowly tune in with us today. I'm really stoked to be kicking off this new stream where previously I was always very deeply focused on a specific topic, whether it's inviting a builder within the Polkadot ecosystem, talk about something very acute, for example, specific CLI tools for doing runtime upgrades, looking at I remember doing episodes with Subbridge and Fala's architecture on Subbridge, for instance. I mean, I have done a whole bunch of live streams that really adopt the format of having a very specific agenda. And for this, me kicking off the Polkadot SDK, or what I really am calling the SDK Unwind, format's going to be very different. I want this to be as accessible as possible for anyone really interested in building with the Polkadot tech stack. And for that, I want to kick things off with welcoming everyone who's tuning in and hope that you guys can tell me maybe more things that you'd like to discover, and we can both discover how to build the Polkadot SDK together. So let's check out who's here. Say hi. So they're streaming on Twitch to kick things off, where next week probably be expanding to YouTube and LinkedIn. But yeah, so for those who are already watching, we for those who are already watching, we're just gonna use this time to like talk about what the stream is going to be. We're gonna use this time for me to give you like a high level understanding of how to build with the Polkadot SDK, what are the things you can achieve with it, and really who's it for, right? Who would be typically using the Polkadot SDK? One of the main things I want to cover today is the high-level components of it, what's it made of, and also highlight that there's been a recent update with regards to where all of these repos that have previously been scattered, where they live and what the reasons for doing that was. So please tune in, say hi, and yeah, let's kick things off slowly. So I hope everyone's grabbed a coffee or has whatever browser open, sort of maybe doing some task while they're kind of tuning in. Hopefully, you can learn something, or at least this stream can serve as a starting point into our world here as Polkadot devs. Yeah, slowly people joining. Let's give it a little bit of time here. So I'm in beautiful Berlin today. We have this wonderful podcast room that I'm using in our Berlin office, Parity. My name is Sacha, by the way. I'm Sacha Lansky. You can find me on Twitter. That's Sacha, SACHAL __, and I pretty active just over there, as well as if you need to reach out to me, you can find me on Matrix. You can always send my contact details for anyone who's curious. I've been working at Parity for about 2.5 years now. Started doing documentation, and I'm still kind of doing documentation. Documentation is a really hard task to get to I was gonna say to get right, but it's more about to maintain. It's one of those things you kind of go with the whole plan and then execute on that plan, and then a lot of things change. A lot of inefficiencies are revealed, and better strategies are revealed only through time, kind of thing. So documentation is really hard. I think that all blockchain, and for that matter, I mean, I think it's especially prevalent in emerging as blockchain like SDKs, where the tech is so new and always changing, but it's applicable to any type of SDK, really. And I think any team who needs to maintain an SDK needs to work with engineering to make sure that it's updated correctly. I think that this is just a really hard task. So anyways, I was just sharing that my entry point into working at Parity was working on the docs, working on tutorials, and really onboarding material for developers using Substrate. So we're gonna go over, what is Substrate at a high level, where does it fit into Polkadot SDK, and hopefully answer some questions that you might have. And I was saying this in the beginning of the stream, the goal of the stream is really to kind of kick back and have a breeze through certain things, pick on things that we might want to dive in deeper as we discover parts of the SDK, and then things that I could be picking up on for the following week. So I will be streaming every week going forward. This is the kickoff SDK Unwind. I'm really stoked to be here today. It's going to be happening on Wednesdays at 3 p.m. CET. That's Berlin time. I believe that would be at 9 a.m. EST, and I'll let you figure out for whatever time zone you are. While I'm sharing this, one of the considerations was to make sure that there's as many time zones possible that can join today. So if you have a strong opinion about making it slightly earlier or later, please let me know. I'd be happy to accommodate. This stream really is for developers entering the Polkadot ecosystem. The stream is for people already building within the Polkadot ecosystem to literally have a place to hang out, to discover things about our tech, and ask questions. And primarily, this is a welcoming space. I want this to be a place for people to come in with their questions, or feel like they can learn a lot, but with the technologies provided by the Polkadot SDK. So let's kick things off. And one of the first starting points here is looking at literally what we mean when we're talking about the Polkadot SDK. So I'll be keeping an eye on the chat if there's any questions. Please just tune in. So yeah, let's kick it off. Let's do it like this. Let me share my screen like this. Okay. So what are we looking at today? So I really wanted to kick this off with what are we talking about with the different components that make up this SDK? So really at a high level, we've actually very recently created a mono repo of all of the things, the libraries that are used to build app chains that can be Polkadot compatible as well as any chain that doesn't necessarily need to be Polkadot compatible, as well as specific modules that can be used by other chains. So let's kind of at a high level identify what those pieces are. And here I've just got the SDK on GitHub pulled up in my browser. We'll go ahead and we will go ahead and check this out in VS Code. So for those that are brand new, clone this and open it up in your browser if you wanted to follow along with what I'm doing and what we'll be discovering. As we go through today's session, I just really want to sort of take things as they come, and that's really the theme of the stream. Like, we'll be going through specific parts of the documentation. We'll be going through what I think are good entry points for people that are completely new to this code base, where there are some tips and tricks to get started. And as we do that, I'll be answering questions. If you guys have any, please feel free and feel welcomed to use this chat, to use this time to ask your questions. And we'll be kind of jumping from one thing to the next, depending on what we're discovering, right? So what I just mentioned, for those that are newly tuning in, we have this mono repo that really has the core libraries to build app chains that are Polkadot compatible, as well as runtimes for these app chains. That means modules that can be put into these the business logic of these runtimes. And please, if there's any jargon that I'm throwing around that's not familiar to you, just let me know, because that's the whole point of this. I really want this to be welcoming for everyone. So jumping right in here, we've got these different folders that make up this Polkadot, this repo. Really, I think it's a great starting point to actually read this README, right? So this README really tells us the information that one would be looking for if they're completely new to this repo. And by the way, again, this repo has recently been put together. I think it was put together on August 25th and published. So a lot of people who even probably were used to using Substrate in the past might be new to this too. So this is also hopefully valuable to those people too. So you'll find that there's these three main folders in the repo we're looking at, right? So Polkadot being the implementation of the Polkadot relay chain. What's the Polkadot relay chain? Essentially, that is the core product that Parity is working on in order to fulfill this vision of the multi-chain future as Polkadot sees it. The second folder here you can see is Substrate. Substrate is another core product that's being primarily maintained by Parity. A lot of community contributions go into Substrate too. And that is an SDK for building blockchains that can but don't need to be, by definition, Polkadot compatible. That's where this third folder comes in, Cumulus. Cumulus is a whole bunch of libraries to make a Substrate blockchain that's maybe unopinionated, that maybe is just a standalone blockchain that isn't, by definition, Polkadot compatible. Well, Cumulus is used to make it Polkadot compatible. That's at a very high level what these three different repos, but there used to be repos. They're no longer repos, Sacha. There are now folders within this monorepo called the Polkadot SDK. So I think that's really like the starting point here, to internalize. And now bringing this up, I've got it on my screen here. So I've cloned this. I have it locally, and I want to just go through each of these key components of this monorepo, and present like what I think is a great starting point if you're new to this, and if you're looking to understand how to use it, as well as some tips and tricks. So welcome everyone. I hope that everyone's having a great day. How's everyone's day going so far? Please feel free to share in the chat, say hi. Okay. I hope that everyone can see my screen. So the first thing I want to just like clarify here is, who is this SDK really for? Like, who would be really using this SDK? And I would break it up into the following sort of builder or audiences. There's some builders that want to create their own app chain. There's some builders that want to maybe create modules for their own app chain. And by the way, when I say app chain, I really mean, to use more general and a term that resonates with a wider audience within the Web3 ecosystem. And in Polkadot's terminology, we really call these app chains parachains. I'm going to stick to app chain because I feel that resonates more with the wider audience. So essentially, you could be building an app chain, and this is the software development kit that you'd be using. You could also be building modules for other app chains to use. This is also the software developer kit that you would be using. You could be looking to extend the underlying core blockchain SDK, which is Substrate. I know it might be confusing. I know that this sort of like way of organizing the repository might be confusing, but really Substrate is the unopinionated framework for building blockchains in general. When you're building a blockchain with Substrate, you're not necessarily confined to building an application specific chain or app chain that is Polkadot compatible. So let's dive in. So we've got Substrate here. Hopefully my screen is large enough. So this folder Substrate contains all of those libraries. So this third audience of this SDK could very well be someone who's extending Substrate for their own use. We've seen builders out there using Substrate to create their own ZK relayers. We've seen people extending Substrate for some very niche use case for, let's say, like having I've seen a layer 1 app chain extend to using a layer 2 as part of their entire infrastructure. There's instances where Substrate really is this flexible and an extendable way to address whatever it is that you're building. And so my emphasis here is that you're not necessarily bound by Polkadot itself. And now let's just kick into what is this this entire folder structure like, and how would you use it? By the way, before we do that, I want to just give a few tips here. So if you're completely new to this repository, I basically strongly advise you to have Rust Analyzer, because as we're going to go through the different parts of the code base, we'll be able to see the documentation for the types and all of the code that we'll be looking at. We'll also be able to kind of make links between some type declarations and where they live and what crates. And so just to be super clear here, you can see that I have Rust Analyzer installed. So there's one problem with Rust Analyzer, is that depending on what machine you have, it's kind of resource intensive. So running Rust Analyzer is a super helpful tool, but it does make your computer heat up, for lack of a better way of saying that. You can see it's enabled for this workspace, so that's pretty cool. Just checking in on the chat if anyone's saying has any questions or anything. Yeah. Okay. So Rust Analyzer is on, and we're just looking at this substrate folder that is a key component of this SDK. And so you can see that it has a bunch of things here, right? So what my advice, if I was like completely new to this code base, I would ask myself, like, wait, Substrate is a library and framework to build custom blockchains. What does a custom blockchain look like? And really, what a custom blockchain looks like, you can find it in this bin folder here. So within this folder, you actually have this node template. So a node template is a bare bones substrate blockchain that you can run and that works, who doesn't need to have any like validator set connected to it. It's got all of the core components of a substrate chain, and it's a really great starting point to kind of look at the different parts that make up substrate chain. So here you can see this is all the code that pertains to the client side. It's in this node folder, and what I mean by client side, it means like all of the consensus operations, all of the sort of off-chain logic, and all of the functionality that's required to have a blockchain running that doesn't pertain to the on-chain business logic of the node. Here you have the pallets folder. So in this pallets folder, the terminology here is important, whereby you have essentially like a pallet is a module. It's just like any Rust module, but it's a special module because it's a module, as we'll see later on in hopefully some future episodes. We can dive deeper in this. It's essentially a module that makes up the business logic of your chain. High level here, not going like too deep. Again, the point is to give you just an overview of like how you would be using this code base and how you can navigate it. For the other piece here, we're in the node template. We're looking at what I think is like, I was new to this code base. I would ask myself, like, what does a substrate blockchain look like at a very high level? You can see it in this bin folder, and now, okay, so we just talked about kind of client consensus, like the off-chain layer. We just mentioned this concept called pallets, and the runtime is where all of the business logic of the node comes together. Hey, Lauren's in the chat. How's it going, Lauren? My day's going great. Yeah, super stoked to launch this SDK Unwind and have a few people tuning in. How's your day going? So we'll kind of get back to this, but I really recommend that this node template is like your starting point to kind of see the bits and pieces. Yeah, episode 0. Let's go. Let's go. Ooh, I can do, yeah. There you are, Lauren. It's like you're part of this now. Okay, awesome. So, we're in the substrate folder, and like the cool thing about this SDK is that there's a bunch of modules that are like already ready to go that you could like just use, put into the business logic of your substrate chain, and this substrate folder has a bunch of these, which again, remember I just said this, that when we were going through the node template, we call these pallets, but they're really just modules. It's kind of like I want to interchangeably use the word like parachains and app chains, like in the spirit of making it more accessible for people tuning in that might be completely new to Polkadot. When I say pallet, just think a Rust module. That's a special module that can be compiled down to the runtime of your substrate chain. Again, if I'm like throwing around a bunch of foreign jargon, even by saying that and by trying not to be mysterious with the terminology I'm using, please just ask questions in the chat. That's what we're here for. We're here to sit back, lay back, and anything that sounds a little weird, anything that's like, ooh, I kind of know what you mean, Sacha, but can we like dig into that a little more? That's what this time is for. So let's use it. And we'll be streaming every Wednesdays from now on. Yeah. Welcome to the SDK Unwind. That's exactly what I like. When I was trying to think about, okay, what kind of stream can I be doing here that's like really valuable? Well, instead of like going really deeply into some very specific topic and have an agenda, I really want this to be a place where every stream we kind of learn something different, learn something new, and bounce from cool concept A to, wow, we just learned some whole bunch of cool stuff here, and we can then revisit those things in a subsequent episode. So let's use this time for that. So okay. And by the way, my awesome colleague Aaron is also going to be doing a stream on frame builders. So he started this earlier in the summer, and it's a really, really awesome way. If you're like already a little more into building with frame, or you really want to learn with building with frame, I notice I'm catching myself say a word that maybe some of you don't even know about yet, but we're going to talk about it just now. Well, Aaron's actually going to be like building pallets, like looking at like storage and kind of a lot more deeper into actually building with something, versus I'm just giving the Polkadot dev community a place to ask their questions, and also a place for me to make sure that everything that's in this SDK is well presented, that things are well documented, because what better place to find those things out by getting your feedback and doing it live. So that's kind of the gist of it. So what is Frame, right? Well, Frame essentially is this library that allows you to build these custom modules that we call pallets. They're really just modules that you can pick and choose to build the business logic of your app chain. Does that make sense? I hope that that kind of makes sense, that people that are watching probably already have a little bit of an idea of what this concept of a runtime is, and if it doesn't, please just ask questions. So you'll find that there's, I don't know how many pallets actually, but there's well over, I think there's well over 100 pallets here. And also there's some other pallets that exist in other repositories. This is just looking at the Polkadot SDK, that is really Parity Technologies blockchain development kit. So there are other repos out there that contain their own custom pallets. These are by all means not all of the pallets that exist in the world, which is pretty cool, right? It's pretty cool because it means that there's a lot of builders out there that are familiar with using Substrate as a library to build their own custom logic that they want to use in their app chains. So, okay, let's take a step back. Let's take a breath here. Why am I even going through this? I started by saying, I want people to feel like they understand, if they're completely new to this code base, what are good starting points? And within this Frame folder, there's this folder called examples. So this, I think, is the best starting point for anyone that wants to understand how to create a pallet, right? How if I wanted to create a custom app chain, sure, I could use these already created pallets that a lot of them are in production already in Polkadot and other blockchains that connect to Polkadot. But if I wanted to create my own, what would I do? So this examples folder is really, really a great starting point. In it, you have an example of a basic pallet. So let's check that out. Let's check this basic pallet out. Okay. Sweet. Yeah, so let's check it out. So basic example. By the way, all of actually, let me just show you a little trick here. So I'm just gonna open up the terminal, and I'm actually just gonna go to this folder here. So remember, we're looking at the Substrate folder. It is one key part. It's just one key part. It's not the only part of the Polkadot SDK. And I'm gonna go into this examples folder, and we're looking at this basic palette. So yeah, you can see. Okay, I'm here. So one of the beauties of using Rust as a language is Rust docs, and every palette has some documentation that can be really useful to just kind of get an idea of what the palette does, and also selfishly, one of my goals for just hanging out every Wednesdays with you guys is to check that it's as good as it can be, right? Developer experience is something we care a lot about at Parity and in our developer relations team. So this is really also a way for me to check that things are well explained, well documented, and yeah. So I'm just gonna show you a little trick. You do cargo doc, and you I'm gonna go examples. Yeah, let's see how. All right. Yeah, because I'll just do palette examples. So, palette examples. This is going to generate the documentation that we see here. And there's a bunch of crates that need compiling. Remember, Rust is a compiled language. When it's done that, then we can open up what the doc's supposed to be seeing. But while it's doing that, and by the way, it'll just be a really neat way to explore what this palette does, and we can see the different functions, and we can see how it's built. But while it's doing that, let's just have a glance over this palette. So you'll notice that every palette has a very similar structure. So like the way that these are really just special modules, right? These are special modules that can be used to create some custom logic inside of your chain. Polkadot, for example, has, I think well over like 40 pallets. We can actually just check really quickly right now the Polkadot runtime. We can check the Polkadot runtime by going to the Polkadot folder, by going then to the runtime folder, and checking it out here. So there's a lot of pallets inside of the Polkadot runtime. So this is all of the pallets in the Polkadot runtime. And like, if you're any block explorer or anything, like looking at Polkadot, you can see this. You can see what the runtime is made of, right? In what we're trying to just discover and unwind here is, if I wanted to make my own palette, what would that look like? So every palette has a similar structure, and we're not going to go like too deep into like actual like, syntax and stuff, but we're just going to go through the kind of the parts of it and what this basic example is really doing. Oh, there you go. The documentation is up, so that's awesome. The documentation is up. So let's pull that up. Oh, I should do open. Sorry, I should dash open. I'll open it. There you go. Okay. So. Yeah, let's do it like this. Okay. Yeah, this is like probably much more friendly, right? Friendly, more approachable. And by the way, this is all of the Polkadot SDK's code base can be accessed through this Rustdoc interface. There's like a CI job that every new code change, this gets updated at a URL that is right here. Actually, I'm gonna share this in the chat. So yeah, this is really great. So that like this is I think that the examples is a much more approachable starting point. So I chose like not to dive right into this, but for those watching, like this is a really, really important link that you can use, that you should use while you're using this code base. This is like, okay, let me say it differently, and let me just say it clearly. This is my number one tip. Check out and always have open this rendering of the Polkadot SDK Rust docs. Let me share this link here. Okay. Yeah, so it's paritytech.github.io/Polkadot-SDK/master. So like this is it just lands on Polkadot service, but not to go down that rabbit hole. I really just want to emphasize the importance of like looking at this documentation that is captured in the code. It's just a nicer way to like visualize it and discover. So right now we're looking at the basic, the palette basic. Oh, check that out. Oh yeah, okay, it's because it's rendered just this, so I have to do, you know what, I'm gonna just do it differently like this, because we can access it from here. So I'm gonna search what I just shared in the chat. Oh, did I even share that in the chat? No, let me do it. Okay, I'm gonna just share this link in the chat. So we have the same thing here that just rendered. We're not going to make any changes, so it's actually not that important to be rendering from my local VS Code. So yeah, just for today, it's like just kind of want to give the lay of the land. So check it out. Yeah, that's the link. That's the link that we're looking at right now. This basic palette, it says a simple example of a frame palette demonstrating concepts, APIs, and structures common to most frame runtimes. Something that is like really crucial to make sure that everyone's clear here is like frame really is this opinionated framework to build these modules. Oh, that's interesting. It's not even rendering like that. That's something that I should fix. Okay, cool. This warrants me. So okay, one of the things that I like to do during the stream is like keep a scratch pad of like things that I'd like to follow up on after when we finish streaming. So let's just do that. I'm gonna just do like, I'm gonna create a scratch pad. The scratchpad.md is where it's gonna be like my to-do list that you guys can hold me accountable to. So wow, Sacha, you're crazy. No, but it's actually really great, right? Like, because like that's the point of this session. It's in on a weekly basis, we'll be kind of going through what I think are like tips and tricks, and like then slowly getting more into the meat and the gritty part of like what would it look like to actually build with these pallets. So we can go through examples and we can really make sure that experience is as good as it can be, right? And there's a lot of room for improvement. So right now what I just discovered is that for some reason when I click on like palette example basic, there's something wrong. The link is broken. So maybe we can just fix that right now. Let's see. Go back to my scratch pad. I'm just still gonna keep it there. So I'm going like SDK Unwind. Okay, so the first thing that we caught is legs broken in examples rest docs. By the way, did I mention like these example palettes are super useful because they're literally where the core engineers are keeping things updated with any new feature or any new I think I was gonna say like, so new features are always coming into frame being this, again, it's just a framework to build runtimes and to build these custom modules, right? So any new feature will actually go into this into one of these example palettes, and also they're also like widely used for onboarding engineers inside of Parity. So really like this is if you want to take something away from this stream like right now, like this is gold. Like go to this examples folder and look around, right? Like have a mosey. So okay, links are broken. Let's try to fix that right now. So why is it broken? I think it's broken because there's this librs that's like the high level thing. And yeah, there you go. Okay, so is there a better way to do this? Okay, so do you see the root of the problem here, guys? We've like so the each of these pallets is just linked as their folder. So like this is just the. I think the initial idea was that it would just link directly to that folder if you click on it. But even if I go like, yeah, no, it's not even getting picked up by our sound analyzer. So let me just try to do that, as I think it would work. So what we're talking about now? Okay, so like I said, like we're kind of gonna discover things as we go. This has nothing to do with Polkadot SDK all of a sudden. It's just like how to document Rust modules, and that's what we're just looking into right now. Because again, my goal is also to, as I'm streaming, is to like identify things that could be better and could be improved. So we want to just test the palette examples basics, and because it's in this. Basically, this is the way that this entire examples folder is constructed. Is that it's made up of a lot of subfolders. But the examples itself, as like Rust sees it, is a module. So yeah, single package with various examples for frame palettes. You can also make this capital. You know what, guys? Like we're gonna probably just end up making a PR after this. So okay. Yeah, if there's any like questions about what I'm doing, just feel free to reach out. So dependency. Okay, so let's treat this. Let's figure out how to do this like Rust doc linting. Linking. Palette example basic. It's not gonna be like that. Okay. How to link to? Yeah, it's gonna be something like crate, I think, and then like. Yeah, let's try that. I don't know. But even if I do this, it should work. Great. Is that it? If I hover over it, then it should catch it. No, it's not. It's not doing that. Okay, if anyone knows the fix of what I'm trying to do, so I'm basically trying to link to this other crate. Bear with me. Let's see what it could be. So to link to another crate in Rust docs. I thought that it did make sense that because remember we rendered it locally, palette examples like the local. Anyways, like it was there, and it still did this, right? So like we have a 404, it just can't be found, and that's because it's going directly to basic, and really we want it to go to. Let me show you right now what we're trying to fix more explicitly. I'm trying to make it go to palette basic. Oh, that's interesting. It's not even. Yeah, palette example basic. Okay. Yeah, so I think that if I do create palette example basic, that should work. Nope, it's palette example. That should work. Nope. Yeah, let's just try re-rendering it to just double check. But usually it would be caught by the Rust analyzer. Like, let me just like be super clear. Like, if those watching, what I mean by that, like, if I go into one of these pallets, and I hover over, say like, um, okay, let's just find like a type in the so if we go like call, and let's just find a call set dummy that should like actually. How interesting. Is my REST analyzer even on? It's not. Huh. It's not on. Maybe I need to reload. Maybe I need to reload. Oh, that's hilarious. Why didn't anyone say something? It was never on. Let's try it again. Okay. Like now it's on. Okay. I was wondering why my computer is oddly cool right now. What I said about REST Analyzer when I had this on the screen for the longest time, I'm just exaggerating, but I was saying that like REST Analyzer is a great tool, but it really takes a toll on your CPU. Therefore, it heats up your computer quite a lot. But it's very useful for our case. Okay, so that's so I don't need to like go in and show you what to expect. I should have it right now. There you go. So all that was missing. Yeah, there you go. It's just loading. That means it's picking something up. So that'll be the change here. Is the stream lagging because of my REST analyzer? I think it might be actually. Check it out. Like, can you hear me? Yeah, Lauren, thanks for this comment. Yeah, it's like if your computer is like oddly cool, you're probably not doing things like something's might be wrong, especially when you're working with substrate. Great comment, Lauren. Okay, cool. No, we hear me fine. Okay, so check it out. Yay. Mais non. Did it work? The rest analyzer. Yeah, so the problem I'm just trying to fix right now is that these aren't good. Let's see. You know what? If I do this again, you'll be able to see whether I can get to that from the rest doc. Oh, so now like the whole thing is it's because REST analyzer is going. It does this thing with the lock file, where because it's using that lock file, it's still working on. Basically, what REST Analyzer does is that it basically like compiles all of the code so that, and it does it, and it keeps updating it as you scroll through. So that's why it takes so much CPU. But hopefully, it's like not gonna take too long. So and I just called the cargo.open command, and cargo also needs to like recompile things. So that's what we're seeing right now. But let's assume that this is the fix. I think it is, and kind of keep going through what we're doing right now, right? So just a quick reminder, like I'm a victim of my own like just trying to do things on the go here, but I realized maybe some people just tuned in and are wondering what we're doing. What we're doing right now is we're just looking at this basic example palette. And one of my tips, my tip number 1 of the day, ching, should have like a pop-up thing where it says tip number 1 of episode 0. Tip number 1 is to check out these example palettes, and what we're doing is looking at the basic example. And the best way to kind of have a high level like first entry point is to check out these REST docs. Yes. So let's check it out. So the basic example palette essentially is giving like some examples of the typical things you could be doing with building a palette. It does also give you some idea of how to document your palette if you were creating your own palettes. So that's pretty useful. Documentation comments should accompany palette functions and be restricted to the palette interface, not the internals of the palette implementation. Okay. Yeah, so selfishly, I can already see like something I can do right now to improve this. Essentially, we already have documentation guidelines stated somewhere. Like this entire block of text is sort of redundant. I mean, we already have these like outlines somewhere. So I'm gonna add this to the scratchpad. I'm gonna add this to our little scratchpad. Okay, so yeah, the first item there is links are broken in example ++. Second is like the example palettes box. No need for repeating doc guidelines. Cool. Okay. So you might be wondering, what do I mean with we already have these doc guidelines somewhere? Well, let me show you. Let me show you right here. So we're going to go into the Polkadot SDK, and this is the Polkadot SDK repo. And in this docs section, you'll see our documentation guideline.md file. And essentially in this, so okay, I mean, like this has all the documentation guidelines. So it covers everything from like top level module, like how to write this like crate level documentation, to how to document specific calls that your module or palette is providing. It really is a very, very comprehensive reference point for people looking to create their own palettes, such that we all kind of like follow the same guidelines. Like it's kind of nice, right, to have like similar, like, you know, a unified look and feel for the palettes that are being created. So this is a great reference point for anyone that is contributing to Substrate and these frame palettes, or going through, or maybe just making a PR and changing some part of a palette and catching a few things that aren't very clear, and that then that person's probably like gonna save a lot of time by just going to this document and referring to it and making sure that it's following these guidelines, instead of like trying to make things up on the go and maybe going back and forth on the PR. Again, like this is just a reference point. It's there to be used. I highly recommend it. And why we're talking about this right now is because what I found is that this kind of repeats that. So in my scratchpad, I'm keeping the scratchpad. Okay. In the scratchpad, I'm going to say like, add this. So we're going to just like make sure that I do that after. Okay, cool. Okay, back to this. Oh, and cool. And this is super great that this is here. I think it's just a little outdated actually now that I'm looking at it. This is like I think the intention here, and we can check how long, like we can check easily, really quickly here when this was created. So if you go to the basic, so there's this template here. I thought that there's a lot of text here. Right. Yeah, there you go. So 4 years ago, this was created, and I think it's a really good idea, by the way. Like the idea is to have just a template for all of these palettes, and like if you're creating a new palette, just like copy paste this template so that, you know, we have a uniform way of doing it, but I think at the time there was no documentation guidelines. And this was kind of us figuring out what these guidelines should look like on the go, but really with a goal to help developers save time, right? So like you have a template that already exists. And so I think that is just some legacy code, or sorry, like just comments in this crate that that's offering a template. So this also should be updated. I mean, I think generally I can just add to my Scratchpad. I can add to my Scratchpad plus check update. Just really, I think we're just gonna have to remove that whole like template section because it's already contained in this documentation guidelines. Like let me just show you guys what I mean. Check it out. This is actually recently created to serve exactly this goal of having a template. So again, like instead of like duplicating this text and for each palette like saying, okay, this is a template like we're looking at here, well, why not just point to that documentation guidelines markdown file, right? That probably makes more sense. So remove the template legacy stuff. Cool. Okay. And oh yeah, we were just okay. So that's already like pretty useful for me. Useful for me to catch these things as I'm going through the various parts of the Polkadot SDK. And like I said, like my goal here is to like present some tips and tricks and stuff. And as I'm doing that, like exploring with you guys and catching things that could be improved, and especially with regards to like how any outsider may experience using this SDK. That's pretty great. All right, so okay. Now let's take a breather here. Let's take a step back from again like going. We're kind of like this is like going into multiple rabbit holes throughout the stream, and like I kind of like that format because it enables like me to improve things. It also enables me to kind of go off on tangents. But I just now taking a step back, like we just went on a tangent. The goal though right now is for me to give you the tip on like how to read about what this palette does and how you can use it. So if this palette is well documented, which we're about to find out, we'll learn a bunch of things here. Okay, so what did I just do, right? So my tip in how to navigate this Rust doc is to go straight to the bottom here. You'll see modules, this modules area. And here, if you click on that, you basically see all of the types of calls, or sorry, all of the different types and things that this palette exposes. You'll see the calls that this palette can make. That means the public calls that anyone can use to make state changes for this module. You'll also see the storage types, so like what this palette's storage layout looks like. You'll then also be able to see the different events that this palette emits. And some super important piece also in any palette is this config trait. So the configuration trait is the types that this palette depends on when you're actually building your own custom runtime with. So yeah, so this is okay. So this is kind of like your entry point, right? You have all of these windows into those respective things from this page here, right? So it's clicking on pallets. let's first take a look at the dispatchable. So I expect that this basic example palette probably has like just like examples of types of dispatchables. Okay, sweet. So we can see there's only two dispatchables here. One is called accumulate dummy. The other is called set dummy. It says, this is your public interface. Be extremely careful. This is just a simple example of how to interact with a pallet from the external world. Okay, let's click into that, the function. Sweet. So clicking into it. Actually, yeah. I'm going to refrain from diving into the code just for the sort of the sake of keeping things a little high level, and then if there's any time and questions left, we can actually go through it. The other dispatchable, again, like at a high level, this palette exposes these two calls. The other call. Ooh, I just said a very specific to Substrate term. I said dispatchable. So essentially in Substrate, the way that we refer to a call or something that can be triggered from the outside of the node is a dispatchable. Because we're very sensitive in Substrate Polkadot SDK world about being as generic as possible. We want the Substrate is built to be the most generic blockchain SDK. And in order to achieve that vision, it's very imperative that we don't sort of pigeonhole ourselves into like implementation specific terminology and whatnot. And that's at least the way that I see this term dispatchable. It's very encompassing of the different types of information that could come to trigger a call. Typically, you would just say, a dispatchable equates to a transaction. Like it's just a transaction. But maybe in one of the other later episodes in this series, we can like actually go into the types of dispatchables out there and why that term actually makes so much sense when you like start appreciating how generic Substrate is as a framework. So set dummy is this other call this palette exposes, and we can expect it's probably just sets a value in storage. So in this example, I think so. Now, as you're like learning about this stuff, cool or a very like informative piece of knowledge is to look at what the storage layout of each of these modules is. So in this examples palette, to look at the storage, we're going to go here, storage types, and here you can see all the different storage items. So bar, counted map, dummy, and foo. Yeah, this is probably. Well, I wonder. I think that this basic palette probably sets out some like fundamental coding patterns for building a palette. But I'm now wondering, like, okay, how can this be improved? And I guess jumping into how the code looks like would be the best way to do that. But yeah, let's kind of table it there. I think I'm gonna go over this, and maybe we can touch on this on the next stream. But at a high level, I think that these can be maybe more informative, right? So like dispatchables, accumulate and set. Like it would be interesting to know like what the purpose of like accumulating, what would be a good use case for having a function that accumulates, right? And I think this set dummy is very similar to another one in the example. So at a high level here, I think we can provide more explanation here. So I'm gonna actually I'm gonna write that in my scrap pad. Provide more explanation around the basic palette. Okay. Sweet. Let's check out our VS Code. Oh yeah, I had the Rust Analyzer going. Rust Analyzer is still going. Yeah, Rust Analyzer is a friend and a foe, but it's really a friend. It's really, really a friend. Again, like I strongly recommend that you have it installed. It makes navigating this SDK a lot easier. It's funny, I can actually hear the background music staggering a bit as it's crunching over here. Explanation. Okay. Let's get back to where like what kicked this entire thing off, which is this examples folder really has a bunch of useful tips and examples on like how to build your own custom palette. And I'm keeping this high level purposefully for like opening the door to questions, and also like keeping things rather open to focus on how this is like documented and how potentially could be improved. So we've already identified a few things. The examples, the basic examples, we've got basic example, default config, dev mode, kitchen sink, off-chain worker, split. Okay. Tip number 2 of the day. This kitchen sink palette actually contains all the different things that you could possibly be doing with Frame. So like it's really like a gold mine for kind of like best practices on how to use this Frame API, right? And let's open it up. Okay, so let's follow a similar pattern as we just did, where we can go, it's going to be called palette example, kitchen sink. Yeah. Nice. Okay. Cool. So yeah, so similar to like when we were looking at the basic example, you have this high-level documentation about the crate itself, and then we can click into the really, it's like the API that this palette exposes, including all the different types it uses, etc. I click here on the palette. I can see the dispatchables, I can see the storage that this palette exposes. And I can also see all these type definitions. Oh, I noticed I glossed over this config trade thing. So I did speak about like how important, like in the design of Substrate and being able to create these modules, how important it is to be as generic as possible. So what's kind of cool about when you're building your own palette, if you have any types that your palette depends on, well, you don't actually need to make those types concrete. You can keep them generic, because who knows, maybe your palette that you're building will be used by some other project or developer that's building their own app chain. And they might have different configurations. So this config trait allows you to specify those configurations in a generic way. So what we're looking at here, I just clicked into the config, and actually this is really nice. It's nicely documented. It explains what the config trait is. The main purpose of this trait, it says, is to act as an interface between this pallet and the runtime in which it is embedded in. The type, function, or constant in this trait is essentially left to be configured by the runtime that includes this pallet. Consequently, a runtime that wants to include this pallet must implement this trait. This sentence in of itself is an entire episode on like how these pallets then actually can be built into making your actual like runtime, which is the business logic of your chain. We're not there yet. We're literally just this is like a nice little entry point to looking at example pallets for those who are eager to start hacking and building their own app chains. And again, like I'm really trying to make this like as open as possible for any newcomers. If there's also people that are well experienced with building with Frame and building their own app chains, it's a great place for you to share any knowledge. So yeah. But yeah, this statement here is basically like a runtime that wants to include must implement this trait. That is how runtimes can actually make pallets, that's how a runtime can specify what these types are when they're concrete. So for example, you can see that this example kitchen sink pallet that has a bunch of like best practices using Frame. Well, it has this currency trait. It's a currency type. Well, this just expects something generic that when you actually use this pallet inside of your runtime, so long as it respects these type bounds, it can be used. So long as it is some type that implements this, you can adjust the way that this pallet is used inside of your runtime. So this config trait is a super important part of any pallet. Just going back into like high level, you can see that this pallet has a bunch of calls, errors, right? Very cool. I want to also note that there's a lot of work that's been put into this kitchen sink, and it's still ongoing. And I think that one of the things that has been really missing in how developers interact with our libraries and this SDK is the disparity between our like substrate IO docs, the docs of substrate IO, and like what examples are provided there, and the actual docs generated by the code base. By taking this approach that I'm like recommending you guys right now, I think that the learning curve is a lot more smooth in terms of like actually getting real world and real examples by referencing these like example pallets, for example, and by being like closer to the source code. Because at the end of the day, when you're building your own palette, you're going to be using similar patterns to what you can find in these examples. So one thing I want to do now, we've kind of already mulled over like looking at these Rust docs and stuff. I just want to actually go into this kitchen sink palette and check it out. So every palette, essentially, when you're making your own, has this lib.rs file, and that's where like all of this, like all of the interfaces to work and build with this palette, where they live. We also have this benchmarking.rs file. So that's something that in of itself can be an entire episode where we kind of just check out what benchmarking is, how to do your own benchmarks. But I'm gonna not go into that right now and just say that benchmarking is a really important part of when you're building a module. You want to make sure that every call that you expose to an external actor, that could be an end user, that could be another pallet, well, whenever that call is made, because that call is actually doing computation and changing the storage of your chain, well, it's imperative in any blockchain environment to estimate what that computation uh, uh, costs for the system as a whole. So you want to make sure that you benchmark each call as you're making your pallets, but that's really only for production. Like you don't need to do that if you're just hacking around with the pallets. Yeah, so benchmarking is maybe we can say like benchmarking could be a but I'll let you guys maybe like you can always like so we're streaming every week here, and the goal is to kind of build off of each episode, not by like, ooh, we're building something and if you miss one of the episodes then you can't follow anymore, but more like, I want to hear your voices as to like things that you want to like explore and discover within this entire code base. And there's so much, like there's a lot of things we could go into. So this test folder, this test.rs file, it contains all the tests. So every module has unit tests. So these unit tests are just checking that functionality is expected. You'll see that some of these some of these pallets will have an actual mock.rs file. They actually decouple the actual tests and the mock. For every tests that you're writing, you need to mock that pallet as it's going to be in the node itself, right? So like you need to actually mock that environment, and so that's why we see like all the code that's here above. That's just like a mock environment. I'm not going into like specifics of like this, what these code blocks are doing, but at a high level, that's your mock environment, and then you have all of these tests pertain to testing functionality of this module. This weights.rs file, like just ignore it. Like, for anyone who's like new in building, this has to do with benchmarking. So I would ignore this file. It's actually auto-generated when you run your benchmarks. Okay. So we're gonna go to the kitchen sink palette. Cool. Kitchen sink palette is very thorough. It actually might be a little too advanced. I don't know. It might be a little too advanced for someone who's completely just discovering this code base and leaning towards it. It's probably a lot of stuff to unpack in this like opening episode. I just encourage you guys to check it out. Like check out this kitchen sink palette and look at the different APIs that it uses, the different functionalities of Frame, right? Frame being an SDK within Substrate to build custom modules, or as we call them, pallets. So let's just glance over it. Let's not go too deep, but like, okay. By the way, huge kudos to Kian for making it and maintaining it also, because it literally has everything you would expect, and all of the things that you could use, right? Like, sorry, just to make it very clear, not all your pallets are going to use everything here, right? This is just like a very thorough source of truth for how to use things and best practices around them. Okay, so at the very top here, there's always going to be a config trait. So the config of your pallet, what we talked about, it allows you to define types your palette depends on, but in a generic way. You can also make them concrete. Like, it's not only that. Like, I think there's an example here. You can literally make it a function. Yeah, I think you could. Like, these are great examples of like kind of unconventional ways. Like, you won't necessarily see a lot of this going on, but that's the beauty of this confusing palette. You can define some extra constants. I've never actually used this. This would be something to like dive in. And notice, like, okay, so one of the scary things maybe for people like entering the world of Polkadot SDK and looking at how to build your own runtimes is all these macros. And these macros, though, are really there to help you stick to writing Rust code without worrying on how to like implement your own storage keys, for example. Like when you define the storage for any of these pallets, it makes some decisions for you, and that's what these macros really help with. They help you write less code, like, right? It does a lot of code for you, so that's really useful. Okay, going into, okay, so we have some storage items. Yeah, there's like so many great examples here of like a storage map actually here. I think Aaron goes through a lot of these like ways to use storage in Substrate and Frame. That's really, really useful. Genesis build. So every pallet actually needs a way to, when it's initialized, when it's added to a chain, it needs to have some sort of like initial configuration of its storage layout. And so sometimes it might be like upgrading a pallet that already exists. So this Genesis build helps define what like the storage layout would look like. Okay, we're just glossing through this palette, and I've come to like what one of the more like crucial parts of a palette, I guess. Not crucial in the sense like super important, but one of the more the things that you're most likely to be working with when you're creating your own palette. Like when you're creating your own palette, you probably want to provide some functionality that the outside world can use. And this is through calls. So we looked at this when we were looking at the Rust docs from this view, when we went into the dispatchables. So dispatchables really like equate to call, like a publicly callable function. That's often what you would see it as. And like you can see, this is, we're looking at the same documentation for the like what we're looking at here. This Rust docs is the same as what we're looking at right here, and you'll see that it's annotated by a few macros. And this is a very common pattern for all calls. Like you always will have some call index, you'll always have some call weight, and then you can declare your function. So again, I'm not going too deep into like what each thing does and everything. I want to keep things fairly high level, and I also want to make sure that the things that I cover are like relevant for people watching. So there you go. Awesome. Okay, and that just reminds me, is this documented anywhere called index? Let's see. Oh, it's loading. It's loading. yeah, so this Rust Analyzer tool, I think because I had it off for the beginning of the stream, and now that I put it on, it kind of messed things up a little bit because it's still running. It's still doing this cargo check, right? That's like Rust Analyzer going in the back. And it's not yet completely settled. And I know that because look, it's kind of, it says loading. Yeah, so that's a little bit unfortunate, because I wanted to show you that like each of these macros actually has their own documentation, so we can like see what they are. Like if I do command click on that, it'll actually bring me to what they call index macro declaration, and which has its own documentation. So let's just do that. Or another way of doing it is like literally I can go here. Oh yeah, funny. I had that open. I watched The Little Mermaid this weekend, and I was really underwhelmed actually. But I think it was a great like motion picture from that perspective. But not I don't know, I really like the original ones. Maybe that's just me. Okay, so let's check this out. We go call index, and I can actually see what I'm trying to, what this call index does. This is just kind of like Polkadot SDK one-on-one, right? Have Rust Analyzer up. Use it so that you can actually see the documentation for all of these like macros that we're looking at or different types that we're looking at, and you use it within your IDE, or actually just go to the Rust docs that's generated here, right? So right now, what we're going through right now is that the Rust Analyzer is still crunching, so we're not able to see it. You can see it says loading, little frustrating, but no worries there, no sweats. We can actually see what this call index is the documentation for it by going to the rendered Rust docs that get this URL. So you can see, okay, each dispatchable may also be annotated with this call index attribute, which explicitly defines the codec index for the dispatchable function of the call enum. This is like very, very like specific to like, so like, no, what I want to say, like, this is really, really great language to like very accurately define what this is. And of course, to a complete newcomer, it might not be that obvious, like what we mean by codec index for the dispatchable function of the call. But it's one of those things that you will like appreciate as you start building using these pallets and stuff. So here it explains it a little more. All call indexes start from 0 until it encounters a dispatchable function with a defined call index. I really like that we came here because like this is a very well documented macro that you instead of like wondering like, ooh, what is this? I'm just gonna write it out. You can actually go to, oh here, look, oh there you go. The Rust Analyzer is, oh it's not, yeah, because it's, there you go. Okay, cool. You can see on the bottom, it's actually, I think it's just checked frame support procedural. And therefore we can see the documentation that's rendered, which is exactly what I wanted to show you guys. Cool. So now like what we're reading here is the same as what we see here, right? And there's a nice warning here about like why this is important. So yeah, super, super useful. Like this would be my tip number 3, I guess now. Like tip number 1 is like have Rust Analyzer installed. Tip number 2, check out these example palettes, and you know, like if you're like already building with Frame and building your own app chain, like they're really great references. Tip number 3, that was number 3. Tip number 4, use Rust Analyzer to actually go to this documentation. So it's really useful, and it explains a lot, right? So you can see what weight does. We're just going high level here on where I don't want to take up the time to go too deep. This is just like an intro to my overall like approach for navigating this code base. And notice like we're already like 1 hour and 40 minutes in the stream, and we've only just looked at so we've literally only looked at what one of these folders contains within one of the folders that's a key pillar to the Polkadot SDK. So what does that say about this SDK? It says that like there's so much to cover. There's so many things. But today, hopefully, like the value is that we've kind of gone through these tips. We've looked at this examples folder that has these pallets, and I'm recommending you check them out. We didn't look at all of them, right? We looked at the basic one, and we looked at the kitchen sink one. And my note there is you might be overwhelmed, but use the Rust Analyzer tool to like check out what all of these functions do. And if you prefer to have like a nicer view of it, just go to this link. Go to this rendered Rust docs that has all of this information. Super cool. So I'm gonna like slowly take a step away from this, and I had something to kind of end this stream with, which is going over a quiz that we did last week and just explaining what the correct answer was, and making sure that we understand what it was. So okay, cool. Did we do that? Oh yeah. Oh, thank God for this scratch pad. So after this, I'm gonna go over this. I'm gonna go over the few things that we've uncovered in this Unwind episode 0. So that's just links. Yeah, the links are broken. We're gonna fix that. There's some repetition that we can fix also, and there's some explanation that could be done within these example pallets, maybe that I can improve here. But super cool. If you have any feedback, by the way, anything that you've caught, like just reach out to me. Okay. So quiz time. Cool. Okay. Let's do it. I'm gonna go. Okay. So there was a tweet. Polkadot devs. It's this one. Oh no. Well, whatever. So yeah, like anyone new here, anyone rewatching this, like the best way to stay tuned with all of our activity within the Polkadot developer ecosystem is to follow us on Twitter. We use Twitter to publish like new streams that we might be doing, and also we're starting to use it to do some fun quizzes and ways to like really engage with you guys a little better, and you know, stream like this is one of them, but there's this other thing that we're doing, and that's the quizzes. If you go check out our quiz, yeah. Oh, there's some fun. Yeah, so there was a question that got answered. Let's see where it is. Oh yeah, by the way, this is really great information about this Polkadot SDK. Like new move to this monorepo. If you have any like concerns and why things have like changed, like this is a great thread to check out. That just reminds me, before I go into this quiz thing. Okay, where is it? We're going to this quiz. Okay, nope, it was later on. I know that. All good. Yeah. Oh, there you go. Yeah, quiz 1. Yeah. Okay. So the question on this quiz is, what is the primary programming language that's used to write smart contracts on Polkadot's substrate? The correct answer is Rust, and I'm going to explain why that is. So when the question is asking writing smart contracts on Polkadot's substrate, the way that actually you can use smart contracts within the Polkadot ecosystem. So if you're building your own app chain, if you want that app chain to be able to execute smart contracts, there's really 2 ways of doing it, which is that you're able to either you're able to like say, okay, I want to go the Polkadot native route and use the native smart contracting language, which is what this question is asking, right? What is the primary programming language to write smart contracts? Or you could easily say, I want to really just be compatible with EVM, like Ethereum-like chains. And so going down that route means you're not so like Polkadot native smart contracts. You're not in that like native smart contracts world. You're able to like have people develop smart contracts and anything that compiles down to the EVM. Okay, so what is the correct answer to this question? Why is it Rust? The native Polkadot smart contracting language is called Ink, and Ink is written in Rust. So if you go to use Ink, you can learn a whole bunch of stuff about Ink and how to use it, what it is, how it differentiates from other smart contract programming languages, like for example, Ink versus Solidity, and Ink versus CosmWasm. And so Ink is the programming language that's designed to execute smart contracts in any WASM virtual machine. So it has a lot of powerful traits, characteristics, and it's also a language that, because it's native to Polkadot and Substrate, that you can actually write contracts that can call into other pallets natively, like in an easy way to configure. So the correct answer to this is Rust, because the native smart contract language is really Ink, and Ink is written in Rust. So it's not JavaScript, it's not Solidity, it's not Python, it is Rust. So yeah, most of you got that correct. There's still a bunch of people that think of Solidity as being the primary language, but again, it could be one language because these Polkadot app chains are able to have the EVM, where you can have an app chain that just has the EVM and doesn't have this other VM that Ink uses, but EVM is not the primary Polkadot native smart contract execution environment. So yeah, hopefully that clarifies it up for you guys, and looking forward to the next quiz. We'll be going through these quizzes on my streams, so yeah, feel free to engage, try to keep follow this Twitter account and answer the quizzes. So yeah, oh yeah, this is what I want to do now to kind of finish up, and what we're going to do next time. Well, today what we did, simply just kind of entry point into the Polkadot SDK. Okay, we did also, and I'm just keeping this for myself and also to inform what the next episode would look like. So what we did, entry point to the Polkadot SDK, we looked at the substrate folder and and went straight into frame, the frame folder. Okay, so I'm gonna say, so we looked at the substrate folder, but we also started by saying like, okay, what would like a substrate blockchain look like? And in bin folder, tip was to check out the node template, and then went straight into frame folder, looked at examples, and yeah, so tips were Rust Analyzer, Rust docs, and examples folder for learning how to build your own pallets. So for the next episode, I think what I really want to do is go into like a pallet that's already in production and explore its functionality and look at how it's built. And we can see probably how to use that in other pallets. And I think that'll be a great piece for episode 2 next week. Ooh, I think I'm misleading you guys by saying next week. We're not going to be streaming next week. I won't be available to take on the stream, unfortunately. So our next session will be the week after next. But next time, jumping into a pallet in prod, how it's built, and how to use it. Cool. Yay, and I have a little to-do list here. Awesome. Okay, so that's kind of wrapping up. Hopefully this is a helpful session, and really like I want this to be I'm repeating myself from the beginning that this is like a session where we're gonna discover various parts of this SDK. It is a wildly extensive and complex SDK, really, where we have all these different key parts. We've only touched on a tiny piece in this kickoff episode, and this is a place for anyone that's new to Substrate and Polkadot and is looking to build applications on it and with Substrate. So this is a place for those people to just come and ask questions and discover with me as I go through the various parts of this monorepo. So with that being said, thanks for everyone tuning in, and we'll catch you next time. Cheers.